I bought green beans, not necessarily to do with this. Can we just have salad?
Yeah. Hello. This is a YouTube live stream broadcast, and I am. It's really just for my students coming up this year in AP's Calculus BC, just to get some help on their summer assignment. If you have any questions, there's really no viewers right now, so you're pretty much going to hear background sounds and stuff until I've got viewers that are asking questions. There is one viewer online right now. I don't know who it is, but hey, like I said on my remind message, just use remind to ask me questions. I have the summer assignment here with me, and I'll go over any problems that you want me to go over. I've got about 45 minutes to an hour, and then I have to go and help make dinner. We're having Thanksgiving dinner in July. We had leftover turkey, so made a turkey today. You might hear my daughter in the background, my wife. You know, it's the hazard of being at home. Not really a hazard. Potatoes. Hey, stop drawing on the counter. Okay, if you just logged in, welcome to, again, this is we've been going for a few minutes here, live stream just to help out, answer any questions. It's basically a Q&A on how, if you have any questions on our AP summer assignment. If you are not in my class and you were just logging on because maybe you're taking AP Calculus and you want to ask some questions, you can ask in the comments, and I'll see what I can do. Again, I'm not going to be on for too long here answering questions. It's summer, and I'm just trying to help you out with your summer assignment, get you ready for calculus as we come up here in about a month before school starts. Where's my, there we go, control room. It's not going very fast. If you're on, and I see that there's 3 people, I think, that were watching. It's not, I'm sorry if it's not coming in too fast here. I guess my Wi-Fi is not working out that great. If you have any questions, you can go and send them on Remind, or you can send them on the comments, the messaging on YouTube. And, yep. my daughter in the background playing. Okay, so I feel kind of silly here just sitting here waiting. So if there aren't any questions, if I don't get any questions in the next 3 or 4 minutes, then I'm just going to kind of end it, all right? Let me go ahead. All right, so we got a question here. Yay! Woohoo! Woohoo! Okay, so we're looking at number 7. The negative goes with the x or the number. 7, A, B, and C. Okay, so I'm not quite sure exactly what the question is, but I do know it has to do with number 7, A, B, and C. So let me do 7A, and then that should help you with the other ones. All right, so you should see that here. So for number 7, we're being asked to determine if, this is 7A, by the way, if this function is odd, even, or neither. So the question here was something about whether the negative is with the x or with the number. So when we're trying to figure out if something is even, odd, or neither, we're looking at 2 things. We've got an even function, and that is if f of negative x is equal to f of x. So if we plug in the negative x for the x and we end up with the original function, then we have an even function. An odd function is a function such that when we have f of negative x, we're going to get negative f of x. So we're going to test this by figuring out what f of negative x is. So we're going to go and plug in f of negative x here, and we're going to get 2 negative x squared minus 7. And notice here we have negative x squared, which is negative x times negative x, which is a negative times a negative, is a positive. So this is just going to give us 2x squared minus 7, which is exactly what we started with. So we can say that that is f of x. So since f of negative x is equal to f of x, that tells us that this is an even function. So we have an even function. Now, if we don't end up with either of these situations, then we're going to have neither. That's what we call it. It's not creative, but that's what it's called, even, odd, or neither. You can factor out a negative, which is what you'll probably do for B. After you do B, you'll factor the negative out to see if you actually get negative f of x. Okay, so hopefully that answers that question. If it does answer your question, just nod. I'm just kidding. I don't see you, so you can nod, but that would be, you're just nodding to yourself. Otherwise, you could just go ahead and say, yes, got it, give me a thumbs up emoji or something like that, and we're good. And the live streaming works out really great when we are able to use Google Classroom, because it's much easier to see to enter in your question on Google Classroom than it is to enter it on Remind. If you do have the Remind app where you have a Remind, you can go online to Remind and you can enter your question there. Okay, so next questions were for number 15 and 16. So we'll go ahead and take a look at those. Now, hopefully you all can see my iPad here. All right, 15, 16. All right, so these are some, I'm not going to say they're fun little questions, but they are questions that we're going to see come up every once in a while in AP Calculus, because there's what we call the definition of a derivative, or and when we get to that, we're going to need to do some algebra that you probably haven't seen really done much of in the past. So 15, f of, we want to find f of x plus delta x. So what you can do is you can treat this delta x, you treat it just like any other variable. It's like if I had an a there, right? So if we had like f of x, you know, f of x plus a, right? So delta x, this whole thing right here, this is just its separate variable by itself. We'll get into, during the school year, we'll get into actually what delta x means and how it relates to calculus, and what it relates to in terms of the actual function in the graph. For right now, just treat it as a variable for this. So we're going to, let's use green here. We're going to plug in this whole thing here in for x in our function. Our function was x squared minus 2x minus 3. So this is going to look like this. It's going to look like x plus delta x squared minus 2 times x plus delta x minus 3. All right, so that is, okay, is the minus 3 coming up? It's not showing up there. Hello again. Hi. Let's try this again. All right, where are you doing, guy? Where is my... Oh, there we go. Okay, sorry, I was just a little slow. Minus 3. So then we're going to simplify that using algebra. So we have a x plus delta x squared, so we need to multiply that by itself. So it's x plus delta x times x plus delta x. And so when I multiply that out, I'll just write it up here so you can see what I'm talking about. Okay. Right, something like that. So we're going to multiply that using FOIL. So we're going to get x squared plus, when we FOIL this out, it's delta x times x. So don't multiply x and x. It's not delta x squared. This is, remember that delta x is its own variable. If you want, you can substitute an a there and then put it back at the end if you want. But it's going to look like this. It's 2x delta x. Okay, because we're going to have an x delta x and we're going to have an x delta x plus delta x squared, because remember it's its own variable, minus, and we're gonna distribute this out, 2x minus 2 delta x minus 3. Wow, my computer looks like it's going so slow right now. I think it's just the Wi-Fi that I'm on. So then I'm going to simplify this, and there's really not a lot simplifying to do. We've got x squared plus delta x squared. Just put the squares together. Plus 2x delta x minus 2x minus, you know what? I really can't simplify this at all. So this is just pretty much our whole thing here. All right. So this problem here is just so that you can see how to plug that in. And then for 16 and 17, you're going to do the same thing that I did here, only you will be able to simplify that out a little bit more because you're subtracting f of x. So you'll have some things drop out. And then I think that delta x in the denominator will also simplify out. So you might need to probably end up factoring delta x from the top and then canceling it out. I'm almost positive that's what happens. It happens with the h as well in 17. Does that help? Did that, I know it's hard for you to communicate with me on this, but hopefully that helps you out on how to simplify that. Really didn't even simplify. We just kind of plugged it in and expanded it. Numbers 16 and 17, in fact, do simplify. So you're gonna want to simplify those out. Hi. Not all light. I'm backlit here. So, ooh, we're up to 5 viewers. That's great. Okay, so we did 7 and we did 15. I'm going to let you kind of think about 16 and 17. Those are you're going to want to do those the same way as I did 15. But again, like I said before, you're going to want to simplify some things out there. And just a hint for 17, find a common denominator on the top once you plug in your x plus h in for your x. So I'll actually, you know what I'll do is I'll give you the first step for number 17, and then you can figure out the rest. How's that? Okay. Let's see. Oops. Let me go ahead and share that with you here. So I'll give you the first step here. The first step for that is going to look like this. Since we're looking for f of x plus h minus f of x over h, the first step is to substitute. So you're going to have 1 over x plus h, because that's what this is, minus 1 over x, because that's what this is, all over h. So this is when I said, like you see right here, you're going to need a common denominator for these two fractions. So find a common denominator for those two fractions and then simplify. All right. Hopefully your summer's been pretty good. I cannot believe that we only have a month left. Should be fun. Oh, good. I helped you out. Good. Great. By the way, welcome to my class. For those of you that are new students of mine, I'm really excited to be teaching AP Calc BC. AP Calculus is like my favorite subject. Or calculus. Calculus is my favorite. I love statistics, though. Love teaching stats class. All right. Why is that not working? Yeah, that's better. My power wasn't plugged in. Maybe that was the problem. All right, so a couple things while I'm waiting for any other questions. You want to make sure that when you're coming into AP Calculus that you have a pretty good feeling with functions. And one of the most important things, it's not functions, but on the side, one of the most important things that you'll need to use in AP Calculus is the unit circle. So hopefully you're feeling pretty good about your unit circle, you know, how well you know the unit circle. And if you don't, then I recommend that you go and you study that. There are a few problems on this summer worksheet, summer assignment, that do have you use the unit circle, particularly just number 27. So number 27 is just kind of a quick understanding, being able to use the unit circle for inverse tangents, inverse cosines, inverse trig functions, and also finding the trig trig of special angles like pi over 4, pi over 3, and being able to use a unit circle to do that. Now, I know in pre-calculus, if you're coming from pre-calculus, you were given a unit circle, and that's not going to happen in AP calculus. You're just going to have to either write it up real quick, but I'll show you some tricks on how to get real quick on that. So the unit circle is important. You'll see a lot of different things that we'll be doing in calculus in terms of context. It's one of the more important things, and that comes from my statistics teaching as well, is that it's really important to know mathematics in context, being able to apply mathematics to the real world, not just, oh, here's some algebra, right? What does it mean? Because that's the important thing, is how sure, it's great to know calculus, but how are you going to use it? Hopefully you'll use it sometime in the future, especially if you're going to be in engineering or sciences or something like that. Okay. Oh, there's my daughter. She's whispering. And my dog. And my wife. Okay. I was just notified that the potatoes are boiling. And I have to go and make mashed potatoes for dinner while they go and pick up my 2 sons from Jedi training class. They're young Padawans in training. Okay, so no questions here. Let me check the message board to see if I have any questions on the chat. Doesn't look like it. Oops. Okay, let's talk about, oh, whoa, bunch of stuff just came up, like all at once. 22A and B. Are we going to be graded for a complete packet or each question? That's a good question, which I will answer after I answer number 22. Well, I might as well just answer that and then get to number 22. So, how are you going to be graded on the summer assignment? The summer assignment is really that you are, one, that you just do it. It's really just an assignment to make sure that you've done some prep work. You'll find that this class is going to go pretty quick, and I'll say this to you on the first day of class about how intense this course is going to be in terms of just the pace. So you'll want to be prepared ahead of time, and that's what most of these problems are, is just to kind of get your mind thinking, all right, I got to remember these algebra techniques. I got to remember how to, find the equation of a line, things like that. So I don't have to go over that again because we're not going to have enough time to review all the stuff that you're supposed to kind of already know when you're coming in. Things that we do need, things that I do need to review, I'll take some time, but we're going to try to minimize that amount of review because we want to get going as soon as we can. Will you be graded on the amount that you get right? No, we just want to know how many you do get right. So we will grade it. I will grade it, and you will get, but basically you're going to get points for doing it, not for having 100% right. So the person that has 50% of them right is going to get the same score as the person who's 100% of them right, as long as they did all of the problems and they attempted all the problems. One thing you'll find in my class, and this is just a philosophy of mine, and those of you that have been my students know this, my philosophy in terms of homework and assignments and things is that, one, I don't really believe that I should really grade you on your correctness for your homework, just because I'm not grading as an assessment. It's more just to see, just for practice. So, when you go to practice anything, there's, you're practicing to get better, to make sure you know how to do it for the big game, or for, for the real assessment. So I can't really give you, points for doing them wrong so much if you're, I'm really not assessing that. So you will find out, though, that there will be sometimes where you know, if you get 100% on a homework assignment or something, some type of assignment that I give you, yeah, you're going to get a few more points than the person that only gets 50. And you'll see that whole grading scheme when I talk to you about it in on the first day of class. So I think it's a scheme, hopefully, that motivates you to stay on top of things, to do work, but doesn't penalize you for not understanding it the first time. I don't expect you to understand things the first time. That just, I mean, who does? Who expects anybody to say, okay, here's how you do it, and then you supposed to master it the first day? I mean, I can't even do that. I'm not even going to remember everybody's name the first time. So practice makes us better at understanding the material. So I'm not gonna be that way. In terms of, like I said, in terms of the summer assignment, it's making sure that's all done. Okay, so make sure you've attempted every problem, and we might have some time to go over some to see what you really need review on the first day. Okay, back to the question at hand here was number 20. What's it? 22 was that? Yeah, 22. Oh yeah. I kind of, when I was looking over these problems, I had a feeling this one was going to be one that would come up. So, okay. So, what can I say about number 22? So, number 22 is a little bit of a lesson in, I guess, not. I would say it's a little bit of algebra thinking outside of the box, and you'll see that a little bit in this class. And that sometimes we gotta switch our brain a little bit in what we're used to seeing all the time in all these cookie cutter type of algebra problems, when it's not always that way. So I'm going to kind of get you started anyway on 22A and give you a couple of hints on 22B, and that might help you with 22B. But they're a little bit different in both of them. So this is 22A. It's a square root of 4x minus 16 over the fourth root of x minus 4 cubed. All right. Now, when you look at this, some people think, well, I have no idea what's going on there. Well, so the first thing you should always think to yourself is, can I factor anything from anywhere? And if the answer is yes, then you should. So the answer is yes. I have a 4 and a 16 here, and I know I can factor a 4 from there. So if I factor out a 4, I'm going to get this. And then if you see anything that looks the same, you should tell yourself, something looks the same. I'm probably going to do something with that same stuff. So we see that x minus 4 and x minus 4 is the same here. So we're going to consider x minus 4 as our major variable there. Okay, so notice that the directions say simplify using only positive exponents and don't rationalize the denominator. So using positive exponents, we've got to convert anything that's a square root or a root into its fractional power. So we know that the square root of 4 is 2. So we're going to go and get rid of that right away. And we're going to make x minus 4 raised to the 1/2 power, because that's what the root is. Similarly, on the bottom, we're going to make x minus 4 to the 3/4 power, because this is a rational exponent with the fourth root is going to be in the denominator, and then the 3 on the numerator. So I know it doesn't look like it's showing up on my computer too well here. So hopefully it'll come up soon. If not, then just listen to what I'm saying. So I've got 2x minus 4 to the 1/2 over x minus 4 to the 3/4. Now, what do we do when we have different exponents but the same base and they're divided? We are going to subtract the exponents. So 3/4 is bigger than 1/2. So I'm actually going to, well, let's go and do this. It's going to be x minus 4 to the 1/2 minus 3/4. And that's going to give me 2 to the x minus negative 1/4, right? Because 1/2 minus 3/4 is negative 1/4. Well, I don't want negative exponents because it said use only positive exponents. So my answer here, I'm going to have to bring this into the denominator, and I'm going to have x minus 4 to the 1/4 power. I can leave it like this. You can leave your answer in that. If you wanted to, you can put it to the 4th root. But notice here, you know, it's a little bit different than what I'm normally used to in maybe an Algebra 2 or pre-calculus class, because I wasn't really dealing with exponents with a binomial inside of it, right? So it's a little bit different. So what I'm going to ask you to do for 22B is I'm going to say the first thing you want to do is convert those into positive exponents, and then actually, you know what you should probably do now that I'm looking at it is, I know this is going to be a little tricky. This is a tricky one. You're going to want to get a common denominator of the 3 fractions so that you can put them into one denominator. And then you're going to deal with that negative 1/2 power. Okay, so that's what I'm going to give you for 22B. I'm going to give you that hint. Find a common denominator. Keep those negative exponents in there until you do your common denominator. And once you get your common denominator, put them all into one, and then deal with the negative exponents, but put them on the top, and then deal with the negative 1/2 power. Because you can't distribute that negative 1/2 power anyway until you've got rid of those pluses. Because you can't distribute the negative 1/2 because of those terms are all separated. Just like right here, I can't distribute that, right? Because I got a minus sign right there. So since I've got a minus sign right there, I can't distribute that 1/2 power. It's not the square root of x minus the square root of 4. That doesn't work. Okay, so there's that one. Hopefully that hint helps. Again, I don't want to give too much away. That's why I'm giving you kind of a hint to see if you can kind of think of some more stuff. For questions 31, 32, do we have to explain why they are identical? You do not have to explain why they are the same. So you just have to circle the 2 that are the same. Explaining why is probably something I should have put there. You're going to be doing some explanation stuff in the AP exam anyway. You're going to need to know how to explain, you know, how to not only write the correct answer or identify it, but justify it as well using vocabulary and language. So being able to justify things is a very key component to this class. This is the information that I'm getting hopefully next week. I'm taking a week-long training on the calculus course, and there's some changes, and I think it has to do with justification. So when it says explain, it really does mean explain justification using words. So if you can, great. Right now, I'm not going to really hound you about it. So right now it says which of the following expressions are identical. All you got to do is identify them. If I did say explain, you will need to explain why they are identical. Okay. Sorry, getting some work done in my front yard, so I was taking a look at that. Okay. So, one last call for, I know I wasn't sitting here too long, but one last call for questions. And then I'm going to go ahead and work on my dinner over there. I'm so excited. I love Thanksgiving dinner. Thank you for joining me today. Hopefully I helped you out. There was only 4 or 5, possibly 6 people here. I didn't really have to do a live stream, but I figured that if anybody could not make it today, this would be the best way that they can get some help on those problems. For those of you that are maybe looking at this video and not really in my class, but are looking at, you know, what types of things do you need to be prepared for AP Calculus? If you're coming in from pre-calculus, you're going to want to be really prepared with your algebra skills. So hopefully your algebra skills are good. And calculus is new, so don't feel don't feel bad about not getting it the first time. Depending on your teacher or your professor, you're gonna need to do some work. So there's definitely some work involved. In my class in particular, we do a lot of talking, a lot of discussing, and a lot of working together. So, but you're gonna want to have, like I said before, you're gonna want to have a unit circle prepared. You're gonna want to have your some algebra taken down. You're gonna want to know how to do piecewise functions. You're gonna want to know how to find the domain and range of functions graphically, and then it would help if you knew something about limits. In terms of a BC class, hopefully your pre-calculus teacher went over vectors. Hopefully they went over parametric equations a little bit, some conic sections, but mostly stuff with polar coordinates. So hopefully they went over polar coordinates and sequences and series. So arithmetic and geometric sequences at least, and then something to do with sigma notation. So those are some of the topics that are in BC that are not in AB. When we do the calculus on sequences and series, vectors, parametric equations, and polar coordinates. And so you're gonna want to be prepared for that. Hopefully your pre-calculus teacher went over that. If you're coming in from Calc AB and you don't remember that stuff, you might want to take a look, go back to your pre-calculus notes and see, just brush up on those topics. Okay, so the last thing I'm going to talk about here, last question before I need to go work on those mashed potatoes, is number 23. And number 23, we're describing words, what these things do. And this is a part that you're going to is really important that you know how to do in translations and reflections of functions, and whether or not it stretches, or vertical stretch, horizontal stretch. So let me quickly go over this as a review, and then I think you can do the problems yourself. So here's a quick review of transformations. So if you have a function, if you add anything to the outside of the function, I know, guys, I don't know why my iPad's going so slow, but it is. So when you add something outside the function itself, that's going to shift this either up or down that many units. All right, so if I had f of x plus 2, that would shift the whole function up 2 units, vertically up 2 units. If it was f of x minus 3, it shifted down 4 units. So up or down depending if it's positive or negative. If I add or subtract inside the parentheses, then that's going to be a shift left or right a units. And it all depends on whether or not it's plus or minus. Now, this is opposite on what you would think it is. So f of x plus a would actually shift it to the left a units, and f of x minus a would shift it to the right a units. So it's kind of opposite on what we think happens, different from the first example where we went up or down, straight up if it's positive or negative, okay? Now, if you multiply a number outside of the function, this is going to be a, sorry about that, not horizontal, it's vertical. This is going to be a vertical stretch by a factor of a. So, if I have a 2 there, then I'm going to vertically stretch this function by a factor of 2. So it's like multiplying all the y values by 2. Whereas if I did it inside, I would shrink or that's a horizontal shrink or stretch. And I would say, think about that anything that's inside the parentheses kind of does the opposite of what you would think it does. So the inside number, if it's a big number like 4, then it's actually going to shrink it horizontally, make it skinnier if it's by a factor of 4. If it's 1/4, then it's actually going to stretch it out by a factor of 4. So, you know, the smaller the number, the stretchier out horizontally, if you will. That's not really a word, but the further it stretches out on the x-axis. So you're like multiplying the x values by 1/a, not just a. You're multiplying by 1/a. Now, if you have a negative in front of the f of x, that flips it. So it flips it over the x-axis. So that's like this. Okay. So that's what's it called? Reflect. Sorry, I couldn't think of that. Reflect around the x-axis. F of negative x reflects around the y-axis. We don't have that very often because you know, we don't really want to reflect things around the y-axis all too often. Well, actually, yeah. And then the absolute value thing for f, just think about what does the absolute value do to a function. It makes all the values, all the y values positive. So it'll keep the x values the same, but make all the y values positive. Basically taking everything that's underneath the x-axis and flipping it up into the y-axis. Or I'm sorry, not the y, but flipping it over the x-axis and making everything positive. For example, if I had a graph that looked like this, if I took the absolute value of that, it would look like this. All right, because I've taken everything that was down here and flipped it up to the top, and that's what the resulting looks like that. Okay, so that's what the absolute value does. You're welcome very much for the live stream. I was doing, hold on, number 28. Seems familiar, but I need some help starting it. Okay, so number 28 through 30 are ones where you have to solve for the function in trig, and you will need to do some, sometimes you'll need to use a trig identity, so you'll need to go back and look at the trig identities. I'll tell you the trig identity for sine 2 theta equals 2 sine theta cosine theta, so you'll need that one for number 30. For 28, the first thing you want to do is put everything to one side, so bring over the sine, and then you're going to factor this. +1 minus 1 equals 0. And then solve for the sine for each of these. And then use the unit circle to figure out what this angle theta is going to be. Okay? All right. Again, you're welcome for the live stream. I was reminded about how important that my students are to me, and I just want to make sure that you are feeling comfortable coming in, and hopefully you're not too stressed out with the summer assignment. I was trying to make a summer assignment that wasn't going to be too intense, you know, too arduous, just some work to kind of get you thinking again. So if you have any other questions, you can go in and email me, and I can see if I can get, you know, if I can answer them back. I will be pretty busy for the next few weeks coming up, but I'll see what I can do. You can also hit me up on Remind, and I'll do the best I can. All right. Okay. So hopefully this was helpful, and I have to go because I got to get dinner ready. So have a great summer. You got about 4 more weeks, I think. 4. It might actually only be 3. So we got a little bit left, summer left. So have some fun. Don't stress out too much. Those of you that are juniors and seniors, those of you seniors especially, hopefully your other AP class summer work isn't tremendous. If it is, don't tell anybody else I said this, but I know this is going to be recorded anyway. But just take some time and go have some fun over the summer. You know, you gotta mellow out. You gotta de-stress before you get stressed because it's going to be intense this year, and you need to have some time to prepare yourself, but to relax and make sure that you're recharged and ready to go. All right, because if you're overly stressed coming into the year, then it's gonna be harder to do that. So my recommendation is just take some time. You know, I know, plan it out, but definitely take a few days to have some fun and do some things and to hang out. Hopefully you've already had a chance to do that. If you haven't, do so. All right, read a book. That's fun to read. Play some video games, or have fun with your pets and your family. All right. So with that said, we will see you in about a month. See you later.